Hello students, how are you? I hope you all are fine and your studies are going good. So till now what we have completed in motion and time, we have studied speed, we have studied about time, we have done questions related to speed, average speed, means different conditions when were given in the questions. Then we did conversion of the speed and its question. Okay, today we will be taking a topic, simple pendulum. Okay, it is an important topic, but before starting it, I told you in the starting when I was teaching you different kinds of motion. In the lecture number 1 I was telling you different kinds of motion. I told you there is a motion that is known as periodic motion. Okay, the motion that is called periodic motion. What is periodic motion? Periodic motion is the motion which repeat itself after particular interval of time. And I told you the example there. The example was simple pendulum or just pendulum. Why it is said to be periodic motion? Because after a particular interval time, it repeats its motion same. Okay, so let's start simple pendulum. How do we make simple pendulum? See, simple pendulum can be made by just tying a stone to a thread. Okay, but during when we do activity or in labs, how is simple pendulum made? Simple pendulum consists of a small metallic ball suspended from a rigid stand by a thread. Means one end of the thread is tied to the metallic ball, and that metallic ball is called bob. What it is called? Bob. And that thread is attached to the rigid stand. Okay, rigid so that it does not break. Clear? So simple pendulum consists of a metallic ball, and that metallic ball is called bob, and it is attached to a thread, and thread is connected to a rigid stand so that it does not break. Okay, now in its rest position, it is called the mean position of the simple pendulum. Getting it? So this is how a simple pendulum is made. It is not necessary that a metallic ball is taken. I have told you even a stone tied with a proper stone tied with a thread can also work as a pendulum. Okay, now we have to look the motion of simple pendulum. Okay, see, it is very important, so please understand it. Now there are certain terms. When I said that it is at its mean position, means rest position, then that position is called mean position. So I denote it with O. So O is here mean position. Okay, and when the motion starts, let's say it is going from O to A. The simple pendulum is going from O to A. The last point till there where it goes and after it returns, that final point is called extreme position. So I have done here A. I have written A over here. So A is the extreme position, and similarly this side also B is the extreme position. Again, remember these two words. O is the mean position, A and B are the extreme position. Getting it? Now let's try the motion. We say it is oscillation motion. You know, I will be telling you what is the oscillation motion, but let's take a look at one oscillation. How does one oscillation complete? For example, I say the motion starts from O. I have started this time the motion from O. So let's see what will be the one oscillation from its mean position. Let's say the bob moves from O to A. Okay, it goes to A. From A, extreme position, it again goes to the mean position, means O. Now O, it will not be in rest now, so it will again move towards right hand side. And here the extreme position is B. So it is coming from O to B. Okay, then again from this extreme position B point, it will again come back to O. This completes the one oscillation of simple pendulum. Again look at it. From O to one extreme position A, again O to B, and then back to O. So every point is covered. When it will come over here, again after traveling this complete motion, then this complete is known as one oscillation. So this is one from mean position to again mean position. O to A to O. But this is not an oscillation, complete oscillation. Again B and then B to O. So this is a complete oscillation. Look at it. O to A, then again O, and then B, and then back to O. So this is one oscillation. Or we can also look at it from other means extreme position also. How? let's see if the pendulum is moving and we starts its reading, or we starts its motion, v from our side starts its motion from A. Then how will it go? From A to O to B to O and then back to A. So this is again a complete oscillation. Means from where it started, it has to reach over there again. This is known as one complete oscillation. Now tell me, is this motion a fix about this particular point O? It is only moving about this point, and this movement about a point to and fro. To and fro means again and again, to and fro. About this A and B, only in this, to and fro, to and fro. So this to and fro motion of simple pendulum is an example of periodic motion or oscillatory motion. So this is what we call oscillation motion. Oscillation motion is a to and fro motion of a particle about any fixed point. Clear? So what you have to remember in this? First of all, you have to remember what is the mean position, that is O. What are the extreme positions, that are A and B. Motion of the pendulum. If it says what is one oscillation, okay, so either you say from it one mean position again back to the mean position like this, and you can also consider one oscillation from extreme position to back to that extreme position again. Okay, see, if it is, say, the question can ask you from A to O and O to B, is that a complete oscillation? No, it is not a complete oscillation. Complete oscillation is from A to O to B, then again O, and then back to A. Is it clear? See, it is very important, oscillation. Okay, because there will be certain terms coming up now, time period and frequency. So you need to understand what a oscillation is. Okay, and then I told you that when a motion is about a point O, for example like this, then this motion is to and fro and known as oscillatory motion. And definitely, you know, simple pendulum is an example of periodic motion. Why? Because if you release it, then it will again start its motion in the same manner as it did in the first oscillation. Okay. So now there are two modes regarding to this motion, that is time period and frequency. Okay. Now look at the definition of time period. Time taken by pendulum to complete one oscillation is called its time period. Means when a pendulum will complete one oscillation, then the time taken by it is called time period. For example, if the motion O to A to B to O, this is taking 5 seconds, means one oscillation is completing in 5 seconds. So the time period is 5 seconds. Okay. See, it need not to be that it will always be more than 1 second. No, it can also be less than. Okay, so again, time period is the time taken by pendulum to complete one oscillation is called time period. Means one oscillation in how much time? That is the time period. Another one is very important, frequency. Number of oscillation in 1 second. It is very important. Now confusion start over here. Time period is time taken to complete one oscillation, and frequency is number of oscillation in 1 second. Okay, here it was one oscillation and here it is 1 second. So frequency is number of oscillation in 1 second, means how much oscillation it does in 1 second. That is the frequency of the simple pendulum. Okay, see, there are numericals related to this. You will understand them better with the numericals, but just take a look over here again. Time period, time taken by a pendulum to complete one oscillation, means one oscillation is like O to A to B and to O. Okay, and frequency is number of oscillation in 1 second. Getting it? So number of oscillation in 1 second means now the time has been fixed in 1 second, and how much oscillation it performs in 1 second, that is the frequency. So I hope it is clear. Now it's time for question of time period, so you can understand it better. So students, the question is, a simple pendulum takes 32 seconds to complete 20 oscillation. What is the time period of pendulum? Here it is asking the time period. Okay, now let's try. Simple pendulum takes 32 seconds. Look at the question. 32 seconds to complete 20 oscillation. What is the time period? Now according to the solution, let's see. What is it is given? Time taken to complete 20 oscillation is 32 seconds. Okay, tell me what is the definition of the time period? Yes, definition of the time period is time taken to complete one oscillation. So these questions are done by simple unitary method. If time taken to complete 20 oscillation is 32, then the time taken to complete one oscillation will be 32 divided by 20. Because the time is given for 20 oscillation. If you have to calculate for one, then you have to divide it by 20. Unitary method. If you have to take the value of a single, so you have to divide it by. So 32 divided by 20, that comes out to be 1.6 second. And the time period now becomes 1.6 seconds. So what does it say? That one oscillation it is completing in 1.6 second. Okay. See, according to unitary method, it is very simple. What if I say that the cost of 12 bananas is rupees 24, and I ask what is the cost of one banana? Definitely you will say 24 divided by 12. What you did? The cost of 12 bananas was 24. Like I will write, the cost of 12 bananas was 24. So the cost of one banana will be 24 divided by 12, and the answer will come 2 rupees. Okay, so this is the this is same here in like a unitary method. Okay, so time taken to complete 20 oscillation is 32 seconds. Time taken to complete one oscillation is 32 divided by 20, that is 1.6 seconds, because we have to calculate of one oscillation. So the time period is 1.6 seconds. Okay. Now say for the similar question, 32 seconds, 20 oscillations, it is asking frequency. Okay. Time period, it was the time taken to complete one oscillation, and frequency, the definition of frequency, number of oscillation in 1 second. So now we can say if number of oscillation in 32 seconds are 20, then therefore the number of oscillation in 1 second is 20 divided by 32. So both are same, but the process is just opposite. It was in time period it was 32 divided by 20, and here it is 20 divided by 32. Getting it? So you can do it by simple unitary method. What I just did number of oscillation in 32 seconds are 20. So what will be the number of oscillation in 1 second? So this will give you the frequency, because what is the definition of frequency? Number of oscillation in 1 second. And similarly time period was time taken to complete one oscillation, that was time period that we calculated just before. So I hope it is clear to you. Again go through this lecture and understand all the terms, time period, frequency, because unless and until you won't understand the terms, you won't be able to do the questions. Once you understand the terms clearly, then you will be easily able to do the questions of time period and frequency. Okay, so take care of yourselves and thank you.